trig substitution. Use the substitution x is equal to 2 tangent theta, where theta is in the first quadrant between 0 and pi over 2 radians, to write the square root of 4 plus x squared as a trig function of theta. So this can be a little confusing perhaps, but we want to get away from x and into a function with theta, and here is our bridge. So this tells me that 4 plus x squared can be written as, the square root of, by the way, 4 plus whatever x is equal to squared. And they tell us that anytime we see x, we can write 2 tangent of theta. Well, let's consider this. 2 tangent theta squared is 2 tan theta times 2 tan theta, which of course will give us 4 plus 4 tangent squared theta. Oh, I know my identities, and that's the theme. If you know your identities, this all becomes easy. So I can see that if I factor out the 4, and I can take the square root of 4 in my sleep, so that's pretty good. I'll get 4 times, if I factor out the 4, 1 plus tangent squared theta. And that's ringing a bell because I know, as an aside, I know that tangent squared theta plus 1 is equal to secant squared theta. By the way, that's because I know my identities. So anytime I see tangent squared theta plus 1, I can write that as secant squared theta. So this expression becomes 4 times secant squared theta. I made my trig substitution, and now I can say, well, what's the square root of 4? It's 2. What's the square root of secant squared? It's secant of theta, and there is our answer. Notice, because our angle was given to us in the first quadrant, ASTC, all students take calculus, I know that the root will be positive. That's why I didn't consider the plus and minus root right here. This is the result we just obtained. Square root of 4 plus x squared is equal to 2 secant theta. Notice here that x is equal to 2 tangent of theta. So tangent of theta is equal to x over 2. And if we're drawing this in the first quadrant, here is theta. And so this represents opposite over adjacent. So opposite over adjacent gives us this. Let's use the Pythagorean theorem. 2 squared plus x squared equals c squared. So 4 plus x squared equals c squared. And we know that the hypotenuse there is always going to be positive. So c is equal to 4 plus x squared here. 4 plus x squared. So secant of this angle, remember, is going to be hypotenuse over adjacent. If we put our eyeball looking through that angle, hypotenuse is 4 plus x squared, and square root over adjacent is 2. So this was our statement. How about 2 of these? If I do 2 of these and I put a 2 out here, then these 2 will cancel, and you can see that we get the result graphically as we did when we did our work with the trig identities as well. Very interesting. Just a note of the techniques we've talked about so far when dealing with trig functions and knowing our trig identities. We factored several ways when we had a difference of perfect squares, and when we didn't have a difference of perfect squares, we introduced a fraction equal to 1, and what guided that fraction was that we were multiplying by conjugates. We combined a fraction by multiplying again by a fraction equal to 1 to make common denominators. We split up a fraction. Remember, when we're splitting up a fraction, you have to have something like a plus or minus b over c. You need that single denominator. And then we had to use substitution of identities to make our expressions more simple. So the better you know your identities, the easier these types of problems will become.